So I'm back and it's episode 2 or day 2. And I know the lighting is not that good right now since I don't really like coding and in a super bright environment. It's a recipe for my migraine. I'm not the highlight of this tutorial, so I'll just make myself a lot smaller. Today, what we are going to do is to build our database models. Basically asking the question, what does our data look like? Now, we need to define what a to-do item or task will look like inside our system. So think of it like creating a form. What information do we need for each to-do tasks? So we will use two types of models. I'll use my LED lights for this one so that it's a lot brighter. So first is our database model, which we will create using SQL Alchemy. And the second one is our API model. It's the structure of the data that is traveling between the front end and back end. In this sense, our front end will travel towards the back end and the back end will send a response towards the front end. So how does that data look? So it's the API model. So I will add a bunch of imports. Don't worry about it right now, but you need to import these libraries here. While we're at it, let's create our database connection. So this is how you connect to the database. So this is how we will prepare our database. All right, so let's get on with it line by line. So on this line, the database URL, this will define our database URL, hence the database URL name of the variable. So this value that we gave to this database URL variable, we basically say that we will use SQLite, which is a lightweight file-based database. And then we will store the database file in our this todos.db. We will store this on our current project directory in the same directory as our main.py file. And of course, the name of the file should be todos.db. And for the engine, this is how we will set a connection towards our database. So we will call the create engine method and then pass in the database URL. And for the connect arguments, we set the check same thread to false. This is required for SQLite only, and it should disable SQLite's restriction on using the same connection on multiple threads. But I think this is safe here because FastAPI handles concurrency with extra care. For the next line, session local, it should create a session, of course, session maker here. As you can see on this part, session maker is the method that we are going to use. It will create a factory function that should return a session object that will let us talk to our database. So we will use this session to talk to our database. We also pass in some arguments. The auto commit equals to false, which basically just means that we need to call the commit method to save our changes so that it's not automatic. And for the auto flush, this will also avoid automatic DB changes. So we will need to use flush or the commit method to update the database. And bind equals engine basically means we are binding our engine to this session, the engine that we have made. And for the last line, which is base equals declarative base, this should create a base class for all our database models. So any class that inherits from this base class will become a table inside our database. I'd like to discuss more about, since I am talking about tables. For example, we have our database here. So this should be called, this is our entire database. This is our todos.db. As I've said earlier, SQLite is file-based database. So this is our file named todos.db, and this should represent our database. And inside our database, there could be multiple tables. So in our case, we will be creating a to-do table, right? Since this table will store our to-do tasks. And you could also add another table here, like for example, users and let's say, I don't know, maybe comments. So I just want to point that out before I continue on. and then I'm gonna paste so I'm gonna paste the code. So don't worry, you're gonna see this code later on, since I would be pushing this branch. So you can see it's episode 2. Our branch is on episode 2. Going back, this is our database model. This is how our to-dos are stored inside our database, and this is the name of our table. It is inheriting from the base class. So this means that we are creating a table inside our todos.db. It's just like this one, right? We are basically creating this one. Let's just delete this to avoid confusion. We are basically creating the table, and what should the table look like? So since we have a table, it should contain columns and rows. So what does our to-do table look like? First, we need an ID, right? This is a unique identifier. So the ID, this is a unique identifier. It should be unique. It should not have any duplicates. This should be unique, since this is what we use to call a specific to-do task. And then we also need a title. Of course, our to-do item should have a title. Our description also. I'm sorry about that. Our description, and completed, if it's completed or not, and the created at. All right, let's go back to our code. So if you notice here, it has a column. So this is how you create columns inside this to-do DB table. Also, you need to specify the name, the table name. We just call it to-do. Let's go back to this a bit and change this to to-dos, since it is our table name. And if we would be adding, for example, a to-do item here, it should look like this. Just create an ID here, and then type here, description, completed, false, created at something that is automatic. So the columns are define the structure of the data, and the rows represent each entry or each to-do item. And then our first column is the ID, which you saw earlier. It should be the integer type. For the title is of type string, and we set the index equals true so that it's easier to search for it. For example, we could use the title as a reference point on what to-do item to fetch. So for the description, we also set it as a string, and it should be nullable, since this description could be optional. So the user has an option to not put any description. And for the completed, it's a boolean type, meaning it's only true or it is false, just the two state. So true can be represented as 1, false can be represented as 0, but in this case we will just use the true or false. And by default, it should be false, since when you create a to-do item, it means that you have not finished it yet, since you created that to-dos. And then for the created at, this is a datetime type or object, and it should default to datetime that UTC now. You don't need to worry about it, but this is the common way of creating this created at. So basically, when you create a to-do item, and if it successfully created that to-do item inside the table or inside our database, then it should get the current date and time in UTC. Since we are done with the database models, we are now going to create our pedantic model. So these define what data we should accept and send via API. So the data traveling from front end, back end, front end. Sorry about that. Because if you remember, I said earlier that we have two types of model. The database model, which is what we are going to be using with SQL Alchemy, and the API model, which is for the pedantic. So this is basically our database model stored in our database, and this is together with the SQL Alchemy. And for this one, let's have a separator here. These are pedantic models. We can say that these are our API models. So pedantic models. So this is the library that we are gonna be using, right, for our API models to verify the shape of our data. So all of these classes, it does a simple task. It should define the shape of the data. So FastAPI will use them to validate the data. For this first class, we are making an API model for when a user creates a to-do item. That's why it's called to-do create. We're also inheriting from the base model here from Pydantic. It's important to keep that in mind. So if a user will create a to-do item, it should contain the title and the description as well. We don't need the created at, and we don't need the completed, since it has default values already. And we also need to specify that the description is optional. If you remember, it's nullable, so it means that inside our table, our description can be null or empty or no value at all, since a user can again have an empty description if he or she is lazy and don't want to describe the task or the to-do item. So yeah, that is for the to-do create. Now, what if we want to update an item? So this to-do update will be used to modify an existing to-do item. All fields should be optional when you update the to-do item, since the user can modify whatever they want. So if they want to change the title, a user can do that. And the user could also update 2 fields at a time or all the 3 fields. It depends on the user. That's why it's optional. So here, this is how our data will look if our user wants to get a to-do item. Okay, so we have created a class when a user wants to create, a class wherein a user wants to update. Now we are creating a class for when a user wants to get a to-do item. All fields should be shown from the response. These are just basically the columns from our table. And this class here just basically tells FastAPI that it's okay to convert SQL Alchemy ORM objects into Pydantic models. If you don't have this, FastAPI wouldn't know how to take a SQL Alchemy object and return it as a JSON response. So this is important if you're working with SQL Alchemy and Pydantic at the same time. So if you're wondering, why don't we have a to-do delete? Because deleting something doesn't usually require a request body. So all of these are part of the request body. So when we perform a delete, it will not have a request body. You just send in an ID. You concatenate it with the URL. So there is no problem with not having a to-do delete class or model. We are actually done with setting up the models for database and for API models. And for the next episode, we would now be creating the CRUD routes, meaning we can create, read, update, or delete using API calls. So I don't want this to be any longer than what I've been discussing. So see you on the next one. Bye-bye.